Well, let's look at now an f-test for linear regression. So this is going to use the F distribution. And now in this case, this is specifically the hypothesis test that the null hypothesis has that beta equals 0, and the alternative is beta is not equal to 0. And so this, with the previous test, we could have tested against any B0, but here, at least my understanding, it could be that we possibly could check other values of beta, but generally speaking, I think certainly it's typically beta equals 0, and I'm not aware of being able to change that. Now, so what we'll see is that we use pretty much the variance of the data. So we are using variance of the Y data, and because of this, these F tests tend to be called analysis of variance, or short, we use the term ANOVA. So analysis of variance. And so if we start with the variance of the Y, now again, this is the one parameter case, and so if we look at that variance, we're taking yi minus y bar squared. Now typically we would divide by n or n minus 1, but we're going to end up with a ratio, so we'll just go with the sum of squares anyway. Now y bar here, if as we look at what that ought to be, if beta equals 0 here, right? So if that's the case, under that null hypothesis, then what you'll have is that this is just the sum of the yi squared. Okay, so we start with that, and then we write that as yi minus yi hat, that is the model, our fit for our data, and then y plus yi hat all squared. And this then, if we square that out, but kind of keeping the yi minus the y hat I together, we end up with yi minus yi hat squared plus a middle term that is 2 times the sum of the yi minus yi hat times yi hat, and then plus the sum of the yi hat squared. Now, we'll show it when we're done with this part, but this turns out to be 0. And so what we get is the sum of the yi minus yi hat squared plus the sum of the yi hat squared, like that. Well, so we call this the residual, this first one here, because that's the error part, or sum of squares error. So we'll call this the sum of squares residual. And then plus, well, this is what we get from our model. So this is the sum of the squares model. And then, you know, under these assumptions of normal distributions, that kind of thing, then it turns out, theoretically anyway, right, if everything's coming from, if our error epsilon for all this was coming from that normal distribution with the constant variance of sigma squared, it turns out that if we look at the number f hat, we'll call it the f hat, 1 n minus 1, so this is going to be our f statistic of the sum of squares model divided by the sum of squares residual, and then times that n minus 1, so the degrees of freedom of our regression. So I'm just going to call that df, okay, which is our n minus 1 here. That is, we can use the f distribution to look at that number, and then our p-value is equal to the probability that an f distribution with 1 and n minus 1 degrees of freedom is greater than or equal to our sum of squares model over sum of squares regression, and in this case times our n minus 1. And so that's how we will check our p-value for this this f-test, is simply looking at that. Let me put some parentheses around that n minus 1. Okay, so that's where we can get that. Now, on the fact that that middle term was 0, well, let's look at the sum of yi minus, nope, not y bar, y hat I times y hat I. Okay, this is the sum of yi times y hat I minus the sum of y hat I squared. Now, y hat, that comes from our model, and this is, so yi, and then we've got our beta hat xi minus the sum of beta hat xi all squared. So this is beta hat, factoring that out, the sum of the xi yi minus beta hat squared times the sum of the xi squared. Okay, now, but beta hat, we calculated that, and beta hat was the sum of the xi yi divided by the sum of the xi squared, and so that's times the sum of the xi yi. minus, and so now we have the sum of the xi yi squared over the sum of the xi squared, and then that whole thing squared for our beta hat squared, and then times the sum of the xi squared. So now on the left here we get the sum of the xi yi all squared over the sum of the xi squared, and then minus, again we get the sum of the xi yi squared. And then, okay, so we've got one of those, and we've got that same term down here squared, and so we end up with the sum of the xi squared, and so we get 0. And there we go. And so that term really is 0, so we really do have our sum of squares total, as we'll call it, is equal to the sum of the squares residual plus the sum of the squares of the model. And then, again, we can create this F statistic with that simply by taking the sum of the squares model divided by the sum of the squares residual, multiplying by those degrees of freedom n minus 1, and that gives us our F statistic, and we can check that for a p-value. So that is the one-parameter hypothesis testing using the F distribution. And it turns out we will get the exact same p-value as the t-test. So this turns out to be the same as t-test. Okay, so we'll call that done.